All right, so we are now actually to the last unit in what you can do with systems of inequalities. This is called linear programming. This is actually a very good tool for determining a lot of things. This particular thing is used a lot in businesses, um, dealing with costs and profit and all that stuff. So we're going to do a couple of examples where we do this. And then what you're going to be asked to do is an activity where there's four different choices and you have to pick, I think it's two. And it's for a grade, so there's no key anywhere in sight. So you will have to do it on your own. So hopefully this will make sense to you. If not, see me and maybe I can go into a little bit more detail for you before you attempt to do the activity. All right, so what is linear programming? It's a method which uses, like I said before, linear inequalities. Forgot the word in there. Sorry about that. Inequalities and equations to determine the optimal solution, the best solution. Of a certain situation. Okay. All right. Now you've got this word constraints. I don't think I used that in my other two videos, but the inequalities that we put down with the shading and everything, those are your constraints. So you can't go beyond basically those constraints. So remember how we were talking about the combined area where the combined shading that we did? That's the same idea with this. When we put in the graph all the systems out, you'll see what's called where that overlap is. It's called the feasible region. We had the big S we were using for shading, but this is called the feasible region. And then we have an objective function, a function that we want to find either minimize or maximize. Again, if you're talking about profits, a lot of businesses like to find the maximum profit, where if you're talking about cost, a lot of companies would like to know what's the minimal cost it will be in order for them to do some stuff. Okay, and then you're going to test the vertices, which we'll talk about, of the feasible region, to determine what's called the optimal solution. Again, the vertices is because it's going to make some sort of shape. Vertices, if you remember, is like the triangle. You know, if it were a triangle or a square, it's the points where the sides connect. Those are called vertices. All right, so I believe this first one will make a triangle when we get done. All right, so let's see if I can zoom out just a hair and see if I can get all this in. Maybe, maybe not. I don't know. All right, so I might have to slide a little bit. All right, so example one says the smallest plane in the coast-to-coast airlines fleet offers first class and tourist class seats. The most it can hold is a maximum of 50 passengers. In order to charter a flight, the airline must sell at least 8 first class tickets and at least 20 tourist class tickets. The company makes $40 profit for each first class and $30 profit for each tourist class. In order for the company to maximize its profits on a single flight, how many first class and tourist class tickets should they sell? All right, so that last part, we're talking about maximizing their profits. So we want to know what will maximize their profits. So we're talking about, first of all, as I said before, when you're reading this, you always, usually the first sentence or two will tell you what the two things are. So in this case, my first class is going to be X and my tourist class is going to be Y. So when I start to write my constraints or writing my inequalities, I will have you figure this out. Okay? All right, so we have here that the smallest plane can only hold so many passengers. So again, usually on these constraints, we have numbers that we have to abide by. There's certain things we have to meet, some requirements that we have to meet. All right, so the first thing is, again, remember that the x equals the first class and the y is equal to the tourist. I don't know why they call it tourist. I would call it economy, but they call it the tourist class. I would call it the economy class. That's reality. Anyway, I didn't write the problem. Okay, so the first thing says that the most it can hold is 50 passengers. So we're going to write our first inequality as being the amount of passengers. So remember, this is the first class. This is the tourists. So the most seats they're going to be able to sell is 50 because that's all the plane will hold. The second thing says they must sell at least 8, which means 8 or more. So our next one's going to be x is greater than or equal to 8. So they have to sell 8 or more. And they have to sell at least 20. Okay, so that's our other. All right, so those are our 3 constraints. Those are our 3. So remember, you've only done 2. Now we have 3 of them. Again, we're going to make most likely some, like I said, a triangle is going to end up forming in the shape. But we're going to do that, and then we're going to test the vertices of the triangle. That's what we're going to end up doing. First thing we're going to do is write down our objective function, and again, that's down here at the bottom where it says the company makes $40 for every first class and $30 profit for each of a tourist class. So our function is profit equals, okay, let me recap. $40 for every first class plus $30 for every tourist class or economy class. All right, so when we get our different vertices, again, I told you it was going to make a triangle, so we're going to have 3 to test. Whichever one gives us the biggest profit is the answer to the problem. All right, okay, so we're going to put these into Desmos over here. So let me go over to Desmos and plug in these 3 things. So x plus y is less than or equal to 50. Okay, again, I don't care what the graph looks like yet until I put all of these things in, and then I'll zoom out. X has to be greater than or equal to 8, and y has to be greater than or equal to 20. Okay, so if I zoom out, there's that triangle I was just talking about. All right, so there's my triangle. So where the overlap is, those are our 3 things. So all we have to do, and Desmos makes it really easy, is I've got to find those points. So 820 is one of my points. Okay, so I'll test 820. All right, I've got to test, what's this one over here? 3020. Got to test that one. I think that's a no-brainer right there. And then the last one is 842. So these are the 3 points. These are the 3 points that I have to test. Now, what's silly is if I looked at these 2 and I was talking about profit, obviously this is going to generate more money than this one will. But I'll test it just for the sake of going through the motions. So P equals 40 times 8 plus 30 times 20. And if you're not really, superb at that, you can just turn around and put that in the Desmos. 4 times 8 plus 30 times 20. And that gives me 920. Okay. Next one is, and again, this is the thing I expect you to do on your activity that you have to do. Is do exactly what I'm doing. All right, and again, since I know you're using a calculator, I'll just expect you to put the stuff written down, but you can calculate. You can calculate using Desmos. All right, this is 1800. All right. Okay, so last one, I'm going to do profit equals 30 times 8 plus 42 times 30. That seems like a lot. So we'll see. Okay, so use this line, and I just type in 30 times 8 plus 42 times 30. That's 1500. So surprisingly, this middle one is the best. So your solution would be that they want to sell, the profits are maximized by selling 30, because it's this guy right here, 30 first class and 20 tourist class tickets. Okay, so you're answering the things in words. Again, I'll just put down here 30, 20, just to remind me that that's what I did. That's the one I picked. And that's how this works. So I didn't spend the time on the video making the graph, but when you do your project, I will expect you to go and graph this, just like, and just follow the directions I gave you in Systems of Linear Inequalities, that lesson, if you need to recap that, to do this piece of it. I just didn't want to spend the time in the time that we had together. All right, so let's just keep going. All right, so we'll keep doing these ones. All right, so let me clear out my Desmos. All right, okay, so now we have Natalie is a hairstylist, and she's making appointments for her clients. She allots 30 minutes for each cut and 2 hours for each cut and color. All right, so 30 minutes for cuts and the other one's cut and color. She has 10 hours available for appointments, and she prefers not to see any more than 8 clients. So each routine costs $40, and each per cut and color costs $100. How many will she, if she wants to maximize her income? Okay, so maximizing profits again. All right, so if we want to, we can do the easy one down here. And her objective, her profit, or her income, if you want to call it I for income. Her income, she makes $40. And again, what's the first thing listed? Make appointments for her clients. She allots 30 minutes for each cut. So again, that's your X. And cut and color, that's your Y. All right, so X is cut, Y is cut and color. All right, and that's the number of, remember, it's number of cuts, number of people doing cuts and colors. Okay, so number of people. All right, okay, so, or sessions, and each session is a person. Okay, all right, okay, so she makes $40 for every cut, plus she makes $100 for every cut and color. All right, so that's my income generated from this, and we want to know which one's the best of the vertices. All right, so first thing she says is she allots 30 minutes for each cut and 2 hours for each cut and color. All right, so the tough part on this, and you have to pay attention, is this is in minutes and this is in hours. So if you want to put it in hours, you can, or you can put it in minutes. It does not matter. Just pick one. All right, so if this is in minutes already, I want to change this to minutes. 2 hours is 120 minutes. Okay, so that way I'm not comparing minutes to hours. I got them all in the same thing. So my first one is going to be 30 minutes. And I think the answer key does it slightly different, but this is the way I'm choosing to do it. Okay, so 30 minutes plus 120 minutes for every cut and color. And she's allotting that. But she is only available for 10 hours, which is, I guess I should have changed this to hours, but I changed it to minutes. This would be 600, right? 60 minutes times 10. 60 minutes times 10. I guess if I were redoing this, I guess I should have put it in as minutes. I mean, instead of hours instead of minutes, but I didn't. So I'm going to go with what I wrote. Okay, so she wants to stay under 600 minutes. Okay, all right, and what else? She doesn't want to see any more than 8 clients. So the number of cuts plus the number of cut and color needs to be less than or equal to 8. Also remember that you always have to be positive or zero. You cannot be negative because you can't have negative clients. All right, so that means x has to be bigger than 0 or equal to 0, and y has to be bigger or equal to 0. You need those constraints again, and putting those in to remind you that you are in the first. That's why if you notice all these are all written with one quadrant instead of all four in regular graph paper, because everything is are things or amounts, and we're never in the negatives. So it's going to be in here. All right, so I got to put all of those things in. So 30x plus 120y is less than or equal to 600. Next one is x plus y is less than or equal to 8. That's the number of appointments she's allowing. And again, she is making sure she doesn't count any negative cuts or negative cuts in colors, because that doesn't make any sense, because you can't have negative things. All right, so I'm going to zoom out. All right, so I can see that all of my shading takes place in this thing. This is where the shading is. So I actually have 1, 2, 3, 4 points to check. So 0, 0 doesn't make any sense, but 0, 0 is technically one of them. But that's definitely not going to maximize her income. That means she didn't work at all. She had no clients. So I would not even test that one, to be honest with you, because that doesn't make any sense. I'm going to put it down as possible answers. 0, 0. What's the one over here? 8, 0. 8, 0. Okay. This one is 4, 4. And then this one is 0, 5. All right, so let me just recap what I've written here. This means she did no clients. This one says she did 8 clients cuts. She did all of her clients, and all the clients that she wanted to have, the maximum number of clients she had was 8. All 8 of them got just a cut. This one says 4 of them got a cut, 4 of them got a cut in color, and this one says nobody got a cut and 5 of them got cut in color. So we want to know which one of these generates the highest income. Well, obviously, like I said, I wouldn't even bother. I wrote it down, but I wouldn't even bother checking that one because it doesn't make any sense. This would be, in fact, I would write down here no income. She's not going to get anything from it. All right, so the first one is 8 zeros. So this is really just 8 times 40. So that's $320. 4 and 4 is 4 times 40 plus 4 times 100. Again, you can put this in Desmos if you want to. That's going to give you $560. And then this one says, okay, I'm doing just 5 cut in colors. That's 500. So according to this, she has to do basically 4 cuts and 4 cut in colors. Cut in color. I'm just going to put clients down there to max her income. Remember that she's only allowing 8 people. If she had unlimited people, then it'd be different. She's only allowing 8 clients total. So you can't have, none of these numbers can be bigger than 8. All right. Okay, so that's what I would write for the solution. All right. I think we're up 20 minutes now, so I think you should be okay with just looking at it really quickly. Yeah, it's the same idea with this one. I guess I could do it, but the profit, let's just write, we won't go through the whole thing. Let's just write up what our equations will be and what our objective function is going to be. All right, so you're baking a tray of chocolate chip cookies, takes 3 cups of milk and 2 cups of flour. Okay, so first thing mentioned is milk and then flour. So milk is X, flour is Y. Baking a tray of oatmeal raisin cookies takes 1 cup of milk and 4 cups of flour. The baker has 9 cups of milk and 16 cups of flour available. He makes $2.50 profit per tray of chocolate chip cookies and $2 profit for any tray of oatmeal cookies. How many trays of each type should he make to maximize his profit? All right, so down here, let's see. Well, first thing we'll do is, again, X is chocolate chip, because that was the first thing meant. Wait, oh, I'm sorry. I got milk and flour. But I'm looking at the trays, and the trays have nothing to do with milk and flour. They have trays of cookies. So I'm going to change that so that X is chocolate chip cookies and oatmeal is Y. So you know, see, and I make mistakes. So the idea here is I've got 2 things, and as soon as I read 2 things, I assumed that. But now that I'm reading it, I've got a tray of chocolate chip and a tray of oatmeal, and that's what's involved in the objective. So remember, X and Y have to represent the same thing all the way through. And since they're asking about how many trays, they're not asking about how many cups of milk and flour. They're asking about trays of types of cookies. So those need to be your X's and Y's. So you can go by the question, how many of each type of appointments, and that will also help you figure out what X and Y are. So X is chocolate chip and Y is oatmeal. Oatmeal. All right, so I now have to transfer this stuff into something I can use. So my first one, we'll talk about milk. So I get 3x plus a thing of oatmeal. Has to be, let's see, she's only got 9 cups of milk, so less than or equal to 9. And then our flour, let's see, the flour, this one's a little trickier. Okay, flour, I got 16, and I use, 4 for the oatmeal and 2. So I use 2 for every chocolate chip, and I use 4 for every oatmeal, and I have to stay under 16. And then again, I would put in my positives in the first quadrant. Again, since I'm using Desmos, that'll help me give a shape there. All right, so then I plug all 4 of these things in, look at the picture. Again, we're talking about how much profit, so he makes $2.50 for every, so his profit is $2.50 for every chocolate chip, plus he makes $2, I'll just put it in there, $2 for every oatmeal raisin, which is Y. That's my objective function. All right, and then I would just, again, find my vertices, and whichever one generates the highest profit for this baker, that's the one we're going to choose. That's all I'm going to talk about. And we're at 23 minutes, so good luck on the assignment and the activity.